In the lab and also in some of our videos, we have looked at how to do some simple arithmetic operations with numbers. We started with integers. We've seen how to do these things with decimal valued numbers. Um, so what we want to do in this video is give you a little bit of an understanding of how we can do slightly more complex evaluations of arithmetic formulae in C. And for this, we need to understand what we mean by an expression in C. We use math formulae all the time in physics, chemistry, and math. And these can be simple, these can be complex, these can be very, very complex. And in C, all of these formulae are evaluated by the computer using a set of rules that we need to be very, very conversant with if we want to not make a mistake in trying to specify our complex formulae in language that C understands. So I've introduced here a term that we haven't seen before. This POW, or power, is a function in the header file math.h. So far, you guys have only worked with stdio.h. Here I have shown you a function that belongs in a different library called math.h. If you want to use the power function in your code, you should include math.h in your header file also, in addition to stdio.h. But we'll look at that later when we actually do some programming using some functions that look like this. So this particular expression, for example, would evaluate y, first typecast the y to a double, and then raise it to the second power. Do the same for z, and then the whole thing would be summed as a double, and then would be typecast to an int, and that would be x. So it's basically the same as this expression, except that we're doing a lot of typecasting in order to be able to use the power function, because the power function takes double-sized variables as inputs and pushes out double-sized outputs also. So all of these mathematical formulae that eventually evaluate to give you a single number are called expressions. Two expressions can be added together to get another expression. Two expressions or multiple expressions can be combined to form new expressions. And this compositionality is what gives C its great expressive power. So any of these expressions that eventually resolve to a single number is an expression. That's what you can define an expression as in C. Expressions consist of one or more variables or constants, and it can contain one or more operators. So for example, you can have C equals A plus B minus 2, where the C, A, and B are variables. 2 is a constant, and equal, plus, and minus are operators. These operators can be of the following types: arithmetic, the ones that we already saw in one of my earlier videos: plus, minus, divide, modulus, multiplication. You also have some other operators, and these are the ones that we will look at in more detail in some of the other videos that we will see in this series of videos. In this one, we just stop with a brief recapitulation of the key arithmetic operators. You can do addition, you can do subtraction, multiplication, division, and remainder, where remainder can only be done for int. Integer division simply gives us the quotient. Float or double division gives us actual real division. These are our arithmetic operators, and we'll be playing a lot with them in our lab.